Good afternoon, students. Let us move to the next model, model number 2, network theorems. Okay, the first theorem, superposition theorem, the different first model basic concepts, active and passive elements, concept of ideal and practical sources, source transformation, source shifting, supermesh, network reduction method, star, delta, mesh and node. The second model, network theorems, superposition theorem, reciprocity theorem, Thevenin's theorem, Norton's theorem, maximum power transfer theorem, Millman's theorem, with and without dependent AC and DC sources. The first theorem, superposition theorem. First, define the statement of superposition theorem. If any multi-store complex network consisting of linear and bilateral voltage across or current through any given element of network is equal to sum of individual voltage and current produced independently across on that element by which source acting independently when all remaining sources replaced by the respective internal impedance. It means individual voltage and current sources produce independent across that each source acting independently, voltage source even the current source acting as independently, and all remaining sources are replaced by respective internal impedance. Here the internal impedance of the source are unknown, independent voltage sources must be replaced by short circuit. Suppose independent voltage source must be replaced by the short circuit. Suppose independent current source must be replaced by open circuit. It means the voltage source will be short circuited, current source will be open circuited. If there are dependent current and voltage source present in the circuit, then such dependent source should not be replaced by open and short circuit. Must be kept as it is. It means if there are dependent current source and voltage source present in the circuit, such dependent source should not replace by open and short circuit. Only independent source will be short circuited, open independent current source will be open circuit. Suppose dependent current source and voltage source will be as it is, kept as it is, must kept as it is. Such source have zero value when the voltage or current controlling them is zero. Superposition theorem, only independent source will be short circuit, voltage source will be short circuited, independent current source will be open circuited. Suppose there are dependent current and voltage source will be as it is, kept as it is. Such source have zero value. Only voltage or current controlling them is zero. The theorem is also known as superposition principle. In other words, it can be stated response of any element linear bilateral network containing more than one source is sum of response produced by sources. More than one source, sum of response produced by source, each acting independently. It means acting as independently. Suppose one source is sum of the sources, the source each acting independently. The response means voltage across element or the current element. Superposition theorem does not apply power as a power proportional to square of current. It is not linear function. The explanation of superposition theorem. Suppose consider one network voltage source E1 and E2, calculate the current branch AB using superposition theorem. Here the two sources, one is the left side E1 at 0 degree, E2 at 0 degree volts. Remaining impedance Z1, Z2, Z3. According to the source independent, the E1 at 0 degree acting independently, at this time the other source must be replaced internal impedance. It means only E1 acting, E2 will be short circuited. E2 is not given the source, E2 must be replaced by short circuited. This circuit means the E2 will be internally, it is not given the source will be short circuited, only acting as E1 at 0 degree. The impedance as it is Z1, Z2, Z3. The current is I1 dash AB. Across the branch AB, the I1 dash AB. Using any of network reduction technique discussed the last chapter, the branch AB, the current is I dash AB due to the source E1 alone. The second case, the E2 is alone. E2 is alone with E1 replaced by short circuit. The second case, this portion will be short circuit. Remaining impedance will be same. The current is I double dash because the case number 2 I double dash AB, the branch AB. The I2 replace short circuited, I1 replace short circuit to obtain the current through AB. The corresponding current, the branch I dash AB dash due to the I2 alone using any network reduction technique. Case number 3. Why case number 3? Because the total current, sum of the source, source equal to sum of the source. These source acting independently. The first current I dash AB, second current I double dash AB. It is sum I dash AB due to I1 E1 source, I double dash due to E2, the sum of two currents. What are the steps superposition theorem? First step, select the single source acting alone, short other voltage source, open current source, internal impedance are not known. It means first the single source acting alone, any the suppose voltage source short circuited, current source open circuit, the first step. The internal impedance are not known. If they known, replace them internal impedance. Second step, find the current through voltage across required element due to the source under consideration using suitable network simplification technique. Find current through the voltage across required element due to the source under consideration using suitable network simplification technique. It means find the current through voltage across required element due to the source under consideration using suitable network simplification technique. Repeat the above two steps for all the sources. First two, single source acting alone, voltage source will be short circuited, current source will open. Second, find current through the voltage across required element due to the source consideration. Repeat the step number 3, repeat above two steps for all the sources. Step number 4, add all the individual effects produced by individual source to obtain total current in the voltage across the element. Okay, just one example based on superposition theorem. Find the voltage V across 3 ohm resistor using superposition theorem. 3 ohm resistors, this voltage will be calculated. Here 6, 2, 8, 3, these are the resistance. 6 and 18 volts voltage source, 2 amps current source. Step number 1, consider 6 volts alone, short 18 volts, open 2 amps. This is open 0, this is also short 0 voltage. First you calculate current. How to calculate current? 6 here 2 and 6, these two parallel means 2 into 6 divided by 2 plus 6, that is 1.5 ohm. 6 divided by 3 plus 1.5. How to get 1.5? These two are parallel, 6 and 2. 6 divided by 1.5 plus 3 equal to 1.3 amps, 1.33 amps, that is total current. Now what is the voltage? Across the 3 ohm, 3 into total current, 3 into 1.33, that is 4 volts. Here 2 and 6 is parallel, 6 volts as it is, 3 ohm. First you calculate this voltage. Second step, consider 18 volts, short 6 volts, open 2 amps. The 6 volts shorted, 2 amps open. Again remains same. Here 3 and 2 will be parallel. These two will be parallel. Because of these two will be parallel. That is 1.2. 18 divided by 6 plus 1.2. That is 2.5 amps. Here the total current is 2.5 amps. What is applying current division rule? Here 3 and 2 is parallel. That is I3 current. Next you calculate I3 current using total current. Current division. I3 equal to IT into 2 by 2 plus 3. What is total current here? 2.5. 2 divided by 2 plus 3. 2 plus 3. Okay, that is 1 amps. That is V dash equal to I3 into 3. What is I3? 1 into 3, 3 volts. Step number 3. Consider 2 amps short 6 volts and 18 volts. Consider 2 amps. 2 amps will be, current source will be considered. Shorted 2 voltage source, 6 volts and 18. These two parallel again. Parallel means 1.5, 3, 2 amps as it is. Current division, I3 current, 2, because the 2 total 1.5, 3 plus 1.5. How to get 1.5? 2 and 6 is parallel, 2 and 6, that you get 1.5. 1.5 divided by 3 plus 1.5, you get 0.666 amps. Next you calculate V triple dash. First V single dash, V double dash, V triple dash. 3 ohm across 3 ohm, plus to minus. Current is like towards, but here direction plus and minus, that is minus 3 I3. That is minus 3 into 0.66, that is minus 2 volts. First is 4 plus 3 V double dash, V triple dash minus 2, that is 5 volts. Okay, stop the video. The remaining next video lecture. Thank you.